It started as nothing more than a flicker, barely a whisper in the data streams flowing from observatories around the world. But when James Webb Space Telescope captured its first detailed image of the mysterious interstellar visitor 3Y Atlas, scientists realized they were witnessing something that could rewrite our understanding of the cosmos. This ancient traveler from beyond our solar system carries secrets that challenge everything we thought we knew about space. The flicker in the dark. The discovery of 3Y Atlas started, not with a bang, but with a faint cosmic flicker detected by the Atlas telescope at Rio Hurtado, Chile in early July 2025. Astrophysicist Matthew Payne at the Minor Planet Center was among the first to flag its interstellar trajectory, confirming that what began as a whisper in Atlas survey data was unlike anything bound to our sun. Days later, a global alert went out to observatories worldwide, and research teams coordinated with NASA's JWS team to track this mysterious visitor. This collective effort led to the crucial moment when NASA released its first image, ultra-detailed and definitive, immediately captivating Dr. Payne's team and the world's top interstellar object researchers. The initial detection required sophisticated computer algorithms to distinguish the object's movement against the crowded stellar background near the constellation Sagittarius. Multiple observatories confirmed the unusual motion patterns within 48 hours, establishing international protocols for rapid follow-up observations. The discovery highlighted how advanced survey systems have revolutionized our ability to detect cosmic visitors that would have remained invisible just decades ago. Beyond the solar veil. Pinpointing the origin, the Atlas team led by Larry Deneau confirmed 3Y Atlas's interstellar status, distinguishing it by its hyperbolic excess velocity well above the escape velocity from the Sun. Analysis by Dr. Karen Meach, who also characterized Oumuamua, showed the orbital data marked its point of entry far above the ecliptic, entering from deep space. Observatories from the European Southern Observatory to Mauna Kea, Hawaii, contributed positional data that painted a picture of an object traveling for potentially millions of years through interstellar space. These collaborative efforts proved this was the third object after Oumuamua and Borisov to have entered from outside the solar system, sparking a fast-tracked global campaign to track and analyze it before it disappeared forever. The object's trajectory suggested it had been wandering the galaxy for eons, carrying pristine materials from its unknown stellar birthplace. International astronomers worked around the clock to maximize observation time, knowing that such visitors offer rare glimpses into the composition and conditions of distant star systems. The coordinated response demonstrated how the astronomical community has learned from previous missed opportunities with earlier interstellar visitors. The accelerating mystery. Why does 3I Atlas exhibit velocity patterns that fundamentally challenge our understanding of celestial mechanics? Scientists conducting comprehensive trajectory analysis have discovered that this enigmatic interstellar visitor displays acceleration characteristics completely unlike typical comets or asteroids native to our solar system. While most celestial objects follow precisely predictable orbital paths determined exclusively by gravitational influences from the Sun and planets, 3I Atlas demonstrates subtle yet scientifically significant deviations from all expected trajectories based on conventional physics models. These anomalous acceleration patterns strongly suggest that forces extending far beyond simple gravitational attraction are actively influencing its motion through space in ways that current astrophysics cannot fully explain. The object's peculiar behavior bears striking resemblance to that of one Oumuamua, which famously displayed mysterious non-gravitational acceleration that completely baffled the global scientific community and sparked intensely controversial theories about possible artificial origins. Early observational data revealed 3I Atlas beginning active cometary outgassing while still positioned 4.5 astronomical units from the Sun, a distance much greater than where typical solar system comets begin their characteristic, volatile sublimation processes. This remarkably early activation, combined with its highly unusual velocity profile and trajectory characteristics, creates an accelerating scientific mystery that fundamentally challenges conventional theoretical models of cometary physics and interstellar object behavior. The extraordinary combination of extreme hyperbolic velocity, unprecedented trajectory parameters and completely anomalous acceleration signatures has forced astronomers worldwide to seriously reconsider fundamental assumptions about how interstellar objects behave when passing through alien star systems, opening entirely new avenues of research into the complex dynamics governing these mysterious cosmic wanderers. Patterns in the void. The intrigue deepened when the Vera C. Rubin Observatory Analysis Group, led by Dr. Zdenka Vokrulicki, noted a trend in the frequency of interstellar objects visiting our solar system. Since the surprise of Oumuamua in October 2017 and 2I/Borisov in December 2019, detection rates have steadily increased, thanks to improved survey technology and, better international coordination. The International Astronomical Union actually convened a special panel to discuss the implications for galactic object exchange, stressing that the regular arrival of such bodies really challenges previous models of solar system isolation. Each confirmed object, now that's 3 in under a decade, forces a rewriting of our assumptions about material drifting between stars and the dynamic nature of our galactic neighborhood. Statistical analysis suggests that thousands of similar objects pass through the outer solar system undetected each year, representing a vast population of interstellar wanderers. The pattern indicates that our solar system sits within a stream of cosmic debris ejected from stellar systems throughout the Milky Way galaxy. And advanced detection capabilities promise to reveal many more such visitors, fundamentally changing our understanding of how matter moves between star systems and the frequency of interstellar exchanges. The machine hypothesis. New web imagery processed by the Space Telescope Science Institute in Baltimore and interpreted by a multidisciplinary panel led in part by Dr. Avi Loeb, set off debate on possible artificial origins. Loeb highlighted unexpected geometry in the object right-angle reflectivity patterns and non-random surface features that seemed inconsistent with natural formation processes. The European Space Agency's JWST spectroscopy division found thermally anomalous regions and odd shadowing that defied conventional models of cometary behavior. Team member Dr. Heidi Hamel, planetary scientist and JWST co-investigator, cautioned that such findings don't yet confirm technology, but the conversation around the machine hypothesis went global after unexpected press releases. The object's surface appeared remarkably smooth and uniform, lacking the irregular features typical of natural space debris that's been battered by cosmic rays and micrometeorites during interstellar travel. Advanced imaging revealed geometric patterns that some researchers interpreted as possible structural elements, though others argued these could result from unusual crystallization processes during the object's formation. The debate really highlighted the challenges of distinguishing between natural and artificial characteristics when examining objects from unknown stellar environments with, potentially different formation conditions. Spectral secrets. Spectroscopic data from the James Webb NIRSpec instrument showed 3I/Atlas contains unfamiliar mixtures of organics, silicates, and metallic alloys, not typical for solar system comets. Dr. Alan Fitzsimmons from Queen's University Belfast identified a significant absorption at 1.5 microns, associated with hydrated minerals, alongside anomalous emission lines unexplained by water or carbon dioxide alone. NASA's Goddard Space Flight Center provided confirmation, reporting faint but consistent microwave emissions that suggested active internal processes. Dr. Jessica Agarwal from the German Aerospace Center noted these combined features could suggest prior irradiation or artificial alteration of native ices, fueling both natural and technological hypotheses about the object's origin. The spectral signatures revealed isotopic ratios that differed from typical solar system materials, indicating formation in an environment with different stellar nucleosynthesis products. Rare Earth elements appeared in concentrations that challenged existing models of planetary formation and cometary composition. And the presence of complex organic molecules typically associated with biological processes sparked additional speculation, though researchers emphasized that such compounds can form through natural chemical processes in interstellar space. The information blackout. So, amid mounting discoveries, global scientists started to notice restricted access to JWST raw data beginning on August 18, 2025. Dr. Joseph Maciero of the Planetary Defense Coordination Office testified that agency data review protocols were now being applied to 3I/Atlas, and well, he cited national security as the reason for limiting information sharing. Meanwhile, SETI Institute researchers, led by Dr. Jill Tarter, raised open letters demanding transparency, and the European Space Agency's Gaia mission team quietly shared independent astrometry with their international colleagues. Tensions really flared during an American Astronomical Society session, when international collaboration took a back seat to agency security reviews. This just revealed the growing friction between open science and government oversight on cosmic anomalies. Scientists expressed a lot of frustration that crucial observation windows were being compromised by bureaucratic delays and, honestly, classification concerns. The controversy really highlighted some fundamental questions about who controls access to cosmic discoveries and whether potential extraterrestrial contact should be subject to governmental secrecy. In response, international researchers began developing independent observation networks to ensure that scientific data would remain accessible to the global community, regardless of individual government policies regarding space-based discoveries and their potential implications for national security. Controlled heat and hidden intent. Thermal mapping using Webb MIRI instruments, supervised by Dr. Michael Werner at JPL, exhibited these adaptive temperature zones across the object's surface, which honestly is not something you see in typical comets. Dr. Christina Thomas at Northern Arizona University presented findings of synchronous heat regulation, and that really stands out, especially when you compare it to the chaotic surface cooling we've seen on icy nuclei, like 67P Churyumov-Gerasimenko. Now, key data obtained near perihelion on August 19, 2025, revealed the stabilization of energy emission regions that actually seem to respond intelligently to solar heating. Theorist Dr. Gregory Laughlin at Yale even hypothesized that such signatures might imply, quote, thermal shielding or technology for intent-driven adaptation, a radical but now openly discussed possibility among planetary scientists. The temperature control followed these predictable patterns that maintained optimal conditions for preserving internal structures, and that honestly suggests either remarkable natural adaptation or deliberate engineering. Computer models showed that natural processes alone just couldn't account for the precision of thermal regulation observed across different surface regions. What's even more surprising is that the controlled heating patterns persisted, even as the object moved through varying solar radiation intensities, indicating active, rather than passive, thermal management systems that really defy our conventional understanding of cometary physics. The prime number message. Analysis teams at the Max Planck Institute for Radio Astronomy, led by Dr. Michael Kramer, detected heat emission modulations that, after Fourier transformation, revealed repeated prime number sequences embedded in the thermal output. Dr. Sophia Sheikh, a SETI researcher, independently validated a 17-23-31 pattern in night-to-night thermal variations using Green Bank Observatory data and, well, some pretty sophisticated signal processing techniques. This prime encoding is considered by scientists, as originally argued by Carl Sagan, to be the most likely signal structure used by non-human intelligences trying to communicate across interstellar distances. The findings, if verified by international SETI groups, could actually represent the first candidate evidence for information intentionally encoded in a celestial object passing through our solar system. The mathematical sequences appeared with statistical significance far exceeding random thermal fluctuations, suggesting deliberate modulation of heat emission patterns. Multiple independent verification attempts confirmed those prime number sequences across different observation periods and wavelengths. The discovery prompted emergency sessions at SETI institutes worldwide, as researchers grappled with the possibility that, just maybe, humanity had detected its first confirmed extraterrestrial communication attempt, though, of course, skeptics continued to search for natural explanations. The Watchers and the Watched. With the International Astronomical Union's special session, the world watched as experts like Dr. Lisa Kaltenegger from Cornell, astrobiologist Dr. Sarah Seeger, Planetary Protection Officer Dr. Catherine Conley, and SETI pioneer Frank Drake reflected on the profound implications of these discoveries. The paradigm has fundamentally shifted. The idea that humanity is the primary watcher of the cosmos has, well, inverted, with 3I Atlas representing potential evidence that we ourselves are being observed and studied. This reversal sparks some really intense debate about whether ethical and existential responsibilities should ever be confirmed, especially with direct, possibly intentional signatures detected in a passing interstellar visitor. The story of 3I Atlas will shape cosmic policy, philosophy, and planetary science for decades to come as humanity grapples with its changing role in the universe. Scientists are now developing new protocols for handling potential extraterrestrial contact scenarios, recognizing that traditional assumptions about human cosmic isolation may no longer apply. The discovery has prompted philosophical discussions about humanity's readiness for contact with advanced civilizations and the implications of being observed by intelligence that may have been studying Earth for extended periods. International cooperation frameworks are being established to ensure unified responses to future encounters with potentially artificial interstellar objects. The first real image from the James Webb Space Telescope begins a bold chapter in cosmic history. As data pours in and global teams compete and cooperate across boundaries, 3I Atlas stands as both a scientific puzzle and a reminder of our shared curiosity about the universe. The search for answers continues to accelerate with each new discovery. Keep exploring the cosmos with Simply Science. Like, share, and subscribe for our next cosmic revelation. Voyager 1 has been humanity's most distant messenger for over 4 decades, traveling through the cosmic void at 38,000 miles per hour, and sending back data from regions no human has ever seen. But here's what will blow your mind. This 1970s spacecraft, built with less computing power than your smartphone, just detected something moving in interstellar space that has NASA scientists working around the clock to understand what they're looking at. The mysterious signal. Voyager 1 just sent back data that has NASA scientists working around the clock, and what they discovered 14 billion miles from Earth is keeping them awake at night. Deep in the cosmic void where no sunlight has touched anything for billions of years, something is moving with purpose and intelligence that defies every law of physics we understand. The signal first appeared as an anomaly in Voyager's plasma wave readings, a rhythmic pattern that shouldn't exist in the empty darkness between stars. But here's what's really unsettling. When scientists ran the data through every possible filter and diagnostic test, they realized this wasn't equipment failure or cosmic interference. This was something real, something structured, and something that seemed to be tracking Voyager's movement through space. The electromagnetic signature doesn't match any known celestial phenomenon, and its behavior patterns suggest a level of complexity that has researchers questioning everything they thought they knew about interstellar space. What makes this discovery even more extraordinary is that the signal appears to be responding to Voyager's presence, almost as if it recognizes the spacecraft as something foreign in its domain. For the first time in human history, we may have encountered something in the depths of space that operates by rules we haven't discovered yet, and it's been watching us from the shadows of the cosmos. Voyager's journey beyond the planets. Right now, as you're watching this video, there's a piece of human technology hurtling through absolute darkness at 38,000 miles per hour, farther from home than any object in human history. Voyager 1 crossed the boundary into interstellar space in 2012, becoming humanity's first ambassador to the galaxy beyond our solar system. But here's what most people don't realize. This region was supposed to be cosmic wasteland, a barren void containing nothing but scattered hydrogen atoms and ancient starlight. Instead, Voyager has been sending back data that's completely rewriting our understanding of what exists in the space between stars. The spacecraft is now over 14 billion miles from Earth, traveling through a realm where our sun appears as just another faint star and temperatures hover mere degrees above absolute zero. This is a place where radio signals from Earth take over 22 hours to reach Voyager, and every piece of data it sends back is like a message from another dimension. What makes this journey even more remarkable is that Voyager was never designed to survive this long or travel this far. It was built for a 4-year mission to Jupiter and Saturn. Yet here it is, decades later, exploring the cosmic frontier and discovering that interstellar space is far more dynamic and mysterious than we ever imagined, setting the stage for encounters that challenge everything we thought we knew about the universe. Unexpected movement detected. Something is defying the laws of physics in the coldest, emptiest region of space, and it's moving in ways that have scientists questioning everything they thought they knew about how objects behave in the cosmic void. The movement Voyager detected wasn't the predictable drift of space debris or the gravitational dance of celestial bodies. This was something actively changing course, accelerating and decelerating with patterns that looked disturbingly intentional. When the data first arrived at Mission Control, engineers thought they were looking at corrupted telemetry because objects simply don't behave this way in interstellar space. But after months of analysis and verification, they realized they were witnessing something unprecedented, an object that seemed to be making deliberate course corrections billions of miles from the nearest star. The movement patterns showed periodic velocity changes that couldn't be explained by solar wind, magnetic fields, or gravitational influences from distant stars. What's even more unsettling is that the object appeared to be adjusting its trajectory in response to Voyager's approach, almost as if it was aware of the spacecraft's presence and reacting accordingly. Scientists have run the data through every known model of celestial mechanics, and nothing comes close to explaining what they're seeing. This isn't random motion or natural orbital mechanics. This is controlled movement in a region of space where nothing should be able to control anything, challenging our fundamental understanding of what's possible in the vast emptiness between stars. Not a planet, not a comet. Every single explanation in our cosmic playbook has been crossed off the list, and what remains is something that shouldn't exist according to everything we know about space. Scientists have spent months systematically eliminating every possible conventional explanation for this mysterious object, and each elimination has only deepened the mystery. Planets don't roam freely through interstellar space, and even the rare rogue planets that get ejected from their star systems follow predictable gravitational trajectories that this object completely ignores. Comets are ruled out because they develop distinctive tails and comas when exposed to stellar radiation. But there are no stars within light years of this object's position to trigger such activity. The spectral analysis shows none of the rocky signatures we'd expect from an asteroid, and its complex movement patterns are far too sophisticated for a simple chunk of space debris drifting through the void. Even exotic celestial bodies like brown dwarfs, neutron stars, and white dwarfs have been eliminated because this object doesn't emit the characteristic radiation signatures that would identify it as any known type of stellar remnant. What's left is something that behaves unlike any natural phenomenon we've cataloged in our centuries of astronomical observation. The object's ability to change course, its apparent awareness of Voyager's presence, and its structured movement patterns have pushed scientists into uncharted territory where conventional astrophysics offers no answers, forcing them to consider possibilities that challenge the very foundations of what we believe exists in the cosmos. Theories behind the movement. The world's leading astrophysicists are proposing theories that sound more like science fiction than peer-reviewed research, and that alone should tell you how extraordinary this discovery really is. One of the most compelling hypotheses suggests we might be witnessing our first direct encounter with dark matter structures that interact with normal matter in ways we never predicted, creating movement patterns that appear almost biological in their complexity. Another theory proposes that this object represents evidence of exotic physics operating on scales we've never observed before, possibly involving magnetic field interactions or quantum effects that only manifest in the extreme conditions of interstellar space. Some researchers have suggested we might be looking at a completely new type of celestial body formed by processes that don't exist anywhere in our solar system, perhaps created by the collision of cosmic phenomena we haven't discovered yet. The most controversial theory, whispered in academic circles but rarely published, is that we might be observing technology of non-terrestrial origin, something that operates by principles we haven't mastered or even understood. What makes this theory particularly unsettling is that the object's behavior patterns show characteristics that some researchers find impossible to explain through any known natural phenomenon. The structured movement, the apparent responsiveness to Voyager's presence, and the sophisticated course corrections all point to something that operates with a level of complexity that challenges our understanding of what's possible in the vast emptiness between stars. Voyager's instruments and their role. 47-year-old technology designed during the Nixon administration is currently making the most groundbreaking discovery in human history. And the irony isn't lost on the scientists analyzing the data streaming back from the edge of known space. Voyager's scientific instruments, built with 1970s computing power that's millions of times less sophisticated than your smartphone, have somehow become humanity's most advanced deep space detective system. The plasma wave instrument has been crucial in detecting the electromagnetic signatures that seem to pulse in rhythm with the mysterious object's movements, creating patterns that resemble communication more than random cosmic noise. Meanwhile, the magnetometer has revealed magnetic field fluctuations that correlate perfectly with the object's position changes, suggesting it's either generating its own magnetic field or manipulating the existing interstellar medium in ways we've never observed. Most remarkably, the cosmic ray detector has shown that this object is somehow creating a shadow in the cosmic radiation background, deflecting high-energy particles in a manner that suggests it has mass and structure far beyond what its other signatures would indicate. These instruments weren't designed to detect artificial objects or analyze unknown phenomena. They were built to study planets and measure solar wind. Yet they're providing us with data about something that operates by rules we haven't discovered, proving that sometimes the most extraordinary discoveries come from tools we never expected to make them.
The distance and speed of the object.
At this very moment, something is racing through the cosmic void at speeds that would make our fastest rockets look like they're standing still, operating in a region of space so remote that light from our sun becomes just another dim star in an ocean of darkness. The object was first detected when it was approximately 500 million miles from Voyager 1, which means it's functioning in a zone where the nearest star system is still over 4 light-years away, a distance so vast that even traveling at the speed of light, it would take 4 years to reach the closest stellar neighbor. What's absolutely mind-blowing is that this object has been clocked moving at roughly 26,000 miles per hour, relative to Voyager's position. But here's where it gets really weird. That speed isn't constant. The object has been observed accelerating and decelerating in patterns that suggest it's not just drifting through space like a piece of cosmic debris. To put this in perspective, even our most advanced spacecraft would require tens of thousands of years to cover the distances this mysterious object has traveled. Yet it's doing so while making controlled course corrections that defy everything we know about how objects move through interstellar space. The fact that something can demonstrate such apparent control over its movement at these incomprehensible distances and speeds raises profound questions about what we're actually witnessing in the deepest, darkest corners of our galaxy.
Why scientists are intrigued.
The most brilliant minds in astrophysics are losing sleep over data that's honestly forcing them to question 40 years of established science. Some are even privately admitting they might need to rewrite the textbooks on what actually exists in interstellar space. This discovery isn't just another interesting anomaly that scientists can, file away and study later. It's actively challenging fundamental assumptions about the very nature of the cosmos that have guided space exploration for decades. For generations, we've operated under the comfortable assumption that the vast regions between stars are basically empty highways, where objects follow predictable paths governed by well-understood gravitational forces. But this mysterious object is behaving like it has its own agenda, moving with a kind of purpose and intelligence that suggests interstellar space might be way more populated and active than we ever dared to imagine. What's really keeping researchers awake at night is the realization that if one object like this exists, there could be thousands or even millions of similar phenomena operating in the cosmic shadows, completely undetected by our Earth-based telescopes. The implications here are just staggering. We might be living in a universe that's absolutely teeming with activity we've never noticed, surrounded by phenomena that operate by physical laws we haven't even discovered yet. This single detection has opened a door to possibilities that range from revolutionary physics to, honestly, the unsettling prospect that we're not alone in ways we never considered, fundamentally changing how we view our place in the cosmic order.
Potential implications for space exploration.
The discovery that's currently sitting on classified desks at NASA headquarters could, completely revolutionize how we design spacecraft and plan missions to the stars. The implications are so profound that space agencies around the world are quietly restructuring their long-term exploration strategies. If this mysterious object represents a new category of interstellar phenomena, it means that the space between stars is far more complex and potentially hazardous than we've been preparing for. forcing engineers to totally rethink how future deep space probes will navigate and survive in regions we thought were predictably empty. The object's apparent ability to manipulate its environment and respond to external stimuli suggests that interstellar space might contain active systems that could either help or hinder human exploration efforts in ways we never really anticipated. From a technological standpoint, understanding the physics behind this object's movement capabilities could unlock propulsion concepts that would make our current rocket technology look, honestly, pretty primitive, potentially reducing interstellar travel times from tens of thousands of years to mere decades. Even more intriguing is the possibility that this discovery could lead to breakthroughs in energy manipulation and field generation that would revolutionize not just space travel, but technology here on Earth as well. The fact that we stumbled upon this phenomenon by accident just highlights how much we still don't know about our cosmic neighborhood, suggesting that future missions equipped with more advanced detection systems might encounter similar objects regularly, fundamentally changing our approach to exploring the galaxy and our understanding of what's possible in the vast ocean of space surrounding our solar system. What could it really be? After exhausting every conventional explanation and running the data through every known model of physics, we're left staring at three possibilities that would each, honestly, fundamentally change humanity's understanding of our place in the universe. The most conservative scientific explanation suggests we've discovered a completely new type of interstellar object. Maybe a category of celestial body formed by exotic processes that don't exist anywhere in our solar system, operating by physical laws we haven't identified yet. A more radical possibility is that we're witnessing our first direct encounter with dark matter structures that can interact with normal matter in ways our current theories never predicted, creating organized movement patterns that appear almost alive in their complexity. But here's the explanation that's being whispered in research facilities around the world, the one that keeps appearing in classified reports. Despite scientists' reluctance to discuss it publicly, we might be observing technology of non-human origin. The object's structured movement patterns, its apparent responsiveness to Voyager's presence, and its ability to make controlled course corrections in the vast emptiness of interstellar space, all point to something that operates with a level of sophistication that, honestly, challenges every assumption we've made about what exists in the cosmic void. Regardless of which explanation proves correct, this discovery represents a watershed moment in human history. The moment we realize that the universe is far stranger, more populated, and more mysterious than we ever dared to imagine, forcing us to confront the possibility that we're not alone in ways we never considered. So there you have it, Voyager's incredible discovery that's honestly challenging everything we thought we knew about interstellar space. Whether this mysterious object represents unknown physics, a new type of celestial phenomenon, or something even more extraordinary, one thing is certain: we're living through a moment of genuine cosmic mystery. What's your theory on what this object could be? Drop your thoughts in the comments below. I really love hearing your perspectives on these space mysteries. If you enjoyed diving into this cosmic puzzle, make sure to subscribe to Simply Science and hit that bell icon so you never miss our latest discoveries from the final frontier. Thanks for exploring the universe with us. What if the third interstellar visitor ever discovered was not a comet, but a billion-year-old alien messenger? In the summer of 2025, a faint object designated 3Y Atlas streaked into our solar system, and a controversial hypothesis immediately captured the world's attention. This was no ordinary rock. The idea of advanced alien technology made global headlines, but NASA quickly stepped in with a powerful, evidence-based response that settled the debate. So what did they find? Let's explore this together. The Atlas discovery in Chile. So, how do we even spot these interstellar travelers in the first place? It starts with a constant, vigilant watch of the night sky. The story of 3I Atlas began on July 1, 2025, at an observatory in Chile. There, a robotic survey system named ATLAS, which stands for Asteroid Terrestrial Impact Last Alert System, detected a faint object at an apparent magnitude of 20, making it about 2.5 million times fainter than the faintest star visible to the naked eye. Led by principal investigator John Tonry, the ATLAS system is a NASA-funded project developed by the University of Hawaii, using its twin half-meter telescopes to scan the entire visible sky every 24 hours. When astronomers calculated the object's trajectory, they saw it was following a sharply hyperbolic path with an orbital eccentricity greater than 1. A definitive sign it wasn't gravitationally bound to our sun. Its orbit was an open curve, meaning it came from deep space and was destined to return there. The object was named 3Y Atlas, with the 3I marking it as the third interstellar object ever discovered. It was racing through our system at a stunning hyperbolic excess velocity of 35 kilometers per second, a truly exceptional catch and a prime target for immediate scientific study. Avi Loeb's controversial hypothesis. Here's where the story takes a sharp turn into speculative territory, thanks to a bold proposal from Harvard astronomer Avi Loeb. While most scientists saw a fascinating natural object, Loeb, known for his controversial work on Oumuamua, offered a different interpretation. In a scientific paper posted to the ArXiv preprint server, Loeb pointed to the object's early lack of a visible coma and its trajectory. He suggested that if the comet continued to show no outgassing, or if its path deviated from a purely gravitational path without a visible tail to explain the push, it could be evidence of something artificial. He even raised the hypothetical possibility of malign intent, though he stressed this was an intellectual exercise meant to keep science open to radical possibilities. His argument, similar to the one he made for Oumuamua, hinged on the idea that any non-gravitational acceleration without a visible coma required a novel explanation. He proposed that a solar sail, a thin, lightweight craft pushed by the pressure of sunlight itself, was one such possibility that science should not be afraid to consider, however unlikely it might seem at first. The physics of radiation pressure are well understood, but for it to be effective, an object must have a huge surface area and an extremely low mass, characteristics not found in natural bodies. Media sensation versus scientific method. Here's the thing about alien theories. They travel faster than light speed in the media. Avi Loeb's hypothesis for 3I Atlas was sensational. Headlines around the world, from online blogs to major news networks, quickly latched onto the most dramatic elements of his proposal, the possibility of an alien craft with potentially hostile intentions. This created a fascinating public spectacle but also highlighted a fundamental tension in how science works. The scientific method is a slow, methodical process that can take months or even years of observation and peer review before any conclusion is reached. In stark contrast, the news cycle operates in mere hours. The global conversation was suddenly centered on a dramatic, unproven idea, while the painstaking work of collecting hard data was just beginning. This put NASA in the position of having to respond not just to a scientific hypothesis, but to a worldwide media event fueled by one of the most compelling questions in human history. It was a classic case of exciting speculation, published on a preprint server before peer review, getting a massive head start on the deliberate evidence-based investigation. This gap between speculation and verification is where misinformation can thrive. NASA's comprehensive investigation. With the debate raging, NASA and its international partners marshaled their most powerful instruments. This wasn't a casual glance, it was a coordinated multi-platform investigation led by Tom Statler, NASA's lead scientist for small bodies. The agency dedicated priority time on the James Webb Space Telescope, using its near-infrared spectrograph or NIRSpec to perform detailed chemical analysis of the gases in its coma. Simultaneously, the Hubble Space Telescope's Wide Field Camera 3 was used for high-resolution imaging to search for any faint dust or fragmentation events with its superior resolving power in visible and ultraviolet light. On the ground, a network of observatories, including the twin 10-meter mirrors of the Keck Observatory in Hawaii, began a long-term monitoring campaign to track its brightness and trajectory with pinpoint accuracy. The goal was to leave no stone unturned, to precisely measure its path to within a few milliseconds, to analyze its chemical composition, and to study its light curve for clues about its shape and rotation. This multi-wavelength, multi-observatory approach is the gold standard in modern astronomy for characterizing a novel object. Comet behavior confirmed. So what does a comet actually do when it gets close to the Sun? The answer to that question was the key to solving the 3I Atlas mystery. As the object continued its journey inward, NASA's array of telescopes watched its every move. The findings were unambiguous. By late July 2025, as it crossed inside the orbit of Mars, 3I Atlas started to behave exactly like a comet. It developed a glowing coma, a fuzzy atmosphere of gas and dust, that eventually grew to over 100,000 kilometers in diameter. Soon after, it began to sprout a tail of dust and gas stretching for millions of kilometers, pushed away from the nucleus by the solar wind. Dr. Lori Glaze, director of NASA's Planetary Science Division, summarized the findings clearly, stating that the object was exhibiting all the classic signs of a comet reacting to the sun's energy. Its initial lack of a tail was simply because it was too far from the sun for its ices to sublimate. The final verdict from the data was it looks like a comet, and it acts like a comet, so there was no need for an exotic, artificial explanation when a natural one fit the observations perfectly. Chemical composition analysis. But confirming it was a comet was just the beginning. The real prize was in its chemistry. A team led by Dr. Anjali Sharma, a planetary scientist at NASA's Goddard Space Flight Center, used the James Webb Space Telescope's spectrographs to break down the faint light from the coma into its chemical fingerprints. The analysis revealed familiar substances like water ice and carbon dioxide, but with a major surprise, 3I Atlas had an unusually high ratio of carbon dioxide to water, measured at nearly 35%. This vital clue suggested the comet must have formed in an extremely cold region of its home star system, far out in its protoplanetary disk where carbon dioxide could freeze out in large quantities. Furthermore, analysis of the dust grains showed a polarization signature with negative branching at a phase angle of 22 degrees, suggesting a surface composed of very fine, porous, fluffy dust grains, a sign of a very pristine, unaltered body. This fluffiness implies the grains have not been heavily processed by heat or collisions, making them a near-perfect sample of their native environment. This chemical snapshot provides invaluable data for models of planetary formation in other star systems. Trajectory and safety assessment. With all the talk of alien technology and, possible malign intent, a critical question had to be answered. Was this object a threat to Earth? The bottom line is a definitive no. NASA's Jet Propulsion Laboratory, or JPL, used the global observation data to refine the comet's trajectory with pinpoint accuracy. Their calculations, made public through the Center for Near-Earth Object Studies, showed its closest approach to Earth would be a distant 1.8 astronomical units, which is roughly 170 million miles. There was never any risk of impact. The comet's orbit was also highly inclined at 60 degrees relative to the ecliptic plane, the flat disk where the planets orbit, meaning it was passing high above the main traffic of the solar system. Its perihelion, or closest approach to the Sun, was calculated to be a safe 1.5 AU, well outside of Earth's orbit. NASA's Planetary Defense Coordination Office was therefore able to declare with certainty that this object posed zero threat. This precise tracking dismantled any notion that the comet could be a danger, allowing everyone to focus on the science. Natural anomalies in cometary physics. So the whole 3I Atlas controversy really boils down to a single fundamental question in science. Is an anomaly evidence of something artificial, or is it a sign of a natural process we haven't encountered before? Science almost always bets on the latter. Our own solar system is filled with comets that behave in bizarre ways. Take Comet 29P Schwassmann-Wachmann, which can increase in brightness by over 15 magnitudes, a factor of 1,000,000, in just a few hours due to cryovolcanic eruptions. Another example was Comet C 2019 Y4, or Atlas, a different comet which unexpectedly disintegrated into multiple pieces as it approached the Sun, showing how fragile these icy bodies can be. The point NASA scientists made is that unusual traits are not automatic evidence of engineering. They're part of the normal, messy, and fascinating physics of icy bodies. These anomalies are not problems for science, they're actually the very data points that lead to new discoveries about how objects form and evolve. So the unique chemistry of 3I Atlas isn't a paradox, it's a clue. Scientific value of interstellar visitors. So, if 3I Atlas is not alien technology, why is it so important? Well, it's because interstellar comets are windows into other worlds. Each one is a preserved time capsule carrying the precise chemical and physical fingerprints of the environment where it formed. For 3I Atlas, the dominance of carbon dioxide and its trajectory suggest it could be over 7 billion years old, originating from the Milky Way's thick disk, a population of ancient stars that existed long before our sun was born. By studying its isotopic ratios, like the deuterium to hydrogen ratio in its water, scientists can get direct clues about the water in other primordial solar systems, which is a key factor in assessing the potential for life elsewhere. This is more than just a curiosity, it's a preserved fragment of another planetary nursery. Future missions like the ESA's Comet Interceptor are being designed specifically to launch and wait in space, ready to chase down the next interstellar visitor for an even closer look. These objects represent a fundamental shift from studying other solar systems through the faint light of their stars to actually analyzing physical samples. Comparing three interstellar objects. Let me explain why having more than one of these visitors is so crucial. By comparing them, we can start to build a bigger picture of the galaxy. 3. I-Atlas was the third interstellar object detected, and it's fascinating how different all three have been. The first one, Oumuamua, was highly anomalous rocky, appearing to have an extreme 10-to-1 aspect ratio, and showing no visible coma, which is what led Avi Loeb to his original theory. The second, 2I Borisov, discovered by amateur astronomer Gennady Borisov, was almost the opposite. It looked and behaved very much like a standard long-period comet from our own Oort cloud, with a chemical composition, specifically a carbon monoxide-to-water ratio of about 0.3, that was remarkably familiar. 3I Atlas falls somewhere in the middle. It clearly behaves like a comet, but its distinct chemical ratios and light-scattering properties make it stand out as unique. This diversity is exactly what astronomers hope to find. It allows them to test whether the processes that shaped our home system are typical, or if we are an outlier. In the end, Comet 3. I-Atlas wasn't an alien messenger, but it did bring an incredible message. It wasn't science fiction, but it delivered profound science. It carried the chemical secrets of its birthplace, a star system far from our own, giving us a rare glimpse into the diversity of worlds forming across our galaxy. The real story isn't about a manufactured object, but about the natural wonder of the universe and our growing ability to study it. If you want more deep dives into the biggest discoveries from space, don't forget to like, subscribe, and hit the bell icon. The universe always has another surprise waiting for us. Thanks for watching Simply Science.